The AM models, we definitely want to do those. Those are pretty cool. We're being recorded.
How's it going? Let's say hi.
Oh, yeah,
Good.
you
How are
remember
you
Tony?
doing?
Yeah, I remember you.
Yeah, yeah. How you doing?
All right.
Oh, good.
So, yeah, that's.
It's so cool. This
That's not your job though, right? Are you doing that like? as a
hobby.
Serious, yeah, cool hobby.
I'm a nerd.
That's just fun. I really, it's just a cool looking thing.
Yeah. Well, we're thinking about, we're gonna sell them. If anybody wants to buy them, we'll sell them.
All right.
You know, like
There was the thing on the bottom, like a.
it is a power over Ethernet switch.
Power over.
Yeah, because we don't like so many plugs. So you have one plug that goes in.
Well,
You plug in here and everything's powered.
okay. Power over, oh, so the
Yeah,
cable are just providing.
Yeah.
But the communication.
exactly. So they're because you got eight lines on your Cat 5.
Yeah.
So you've got 45 volt power. You have two transmits, transmit, a receive. And I think 4 of them aren't even used, but yeah, you have plenty of power.
But that's handling communication between all the two.
Correct. There's no Wi-Fi. It's all hard line. Yeah. Now we can.
So that's like a router.
Yeah. Yeah. Matter of fact,
And then-
if you buy a bunch of them, you can chain them together. You have the extra port. You can chain them.
Or under the internet.
Yeah.
I mean,
Sure. Whatever.
maybe. And are those,
Those are Pi 4s, not the 5s.
what?
These are 4s though, not 5s.
I don't know. I just know. Pretty deep.
It's cool though. Like, yeah. But the AI stuff, that's gonna be super cool. Because we want to start setting up Alexas out of your house where you don't have to pay a subscription.
Alexa, that goes to Amazon or that just
Yeah.
does everything that
No.
Alexa does?
Basically an Alexa that doesn't report everything you say back to somebody else.
I have a friend,
So we're gonna set up a broadcast from graveyard when the production here, so we're.
Works for my job.
Getting started.
got solar panels on the roof, batteries in his garage, just wired his entire room to his smart house. And make sure that everything you pick is internal, like nothing goes on the.
Yeah,
Right.
that's what we're trying to do.
Yeah. You would.
That's exact. Well, I have to tell them. We'll
Yeah.
Yeah.
Because we have the,
We have them, like we have the clusters and they're streamable, so you get whatever compute he wants.
You probably have these already, but just,
Yeah, sure.
actually, there's a group of friends that, actually the two. Well, I liked the rear end of it and the,
You like the rear end more?
well.
Okay.
Okay.
we don't judge.
We say that for HR.
Yeah, thank you. But yeah, you got two of them, so you can get all angles.
Yeah,
They're beautiful.
they're so easy to install. Huh?
Yeah.
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 So yeah, I have another repo, like we're going over the source code for this class, but I have another class that I like to do where we install a Kubernetes cluster on the Raspberry Pi and deploy applications to it. And then I talk about how if you plug in like a Wi-Fi camera to one of the worker nodes, you can make sure that only pods that relate to filming connect to that node and none of the others. So now you suddenly decide I want to add CPU stuff with CPUs. You plug in the USB on one of the ports and you add a label and saying this is now an AI worker node. And your pods will pick up instantly. And if you don't have it, your pod will sit in a pending state until you plug it in.
Like all these parts you bought. You put them together.
He's the manufacturer.
Actually, I did make the case layers, the ones you see, the plastic. Yep, those.
The wicked world.
Uh-huh.
That's you?
Yeah.
Oh, nice. Okay. All right. And then I don't know, Raspberry Pi is like in 2 layers.
It's one's
It's
called a NAS.
right, it's the,
But yeah.
right, the Pi itself and then the PoE hat.
Because you have to
Makes
convert,
one.
you got to convert the 45 volts down to 5 volts.
Okay. And that makes one.
Right.
Yeah.
And then like the little extensions or whatever you call them, like you buy
Yeah,
them on the shelf.
Yep.
Together.
Yeah, the,
It's really beautiful. I would say.
Wow, I like your phone. That's pretty
Yeah.
good.
Oh, yeah.
But yeah, we'll have to talk more. I apologize. I can't talk.
Yeah.
No, not at all.
I was so frustrated with
I knew you were.
Amazon.
yeah,
And I did reach out to Jeff Budge, and he just, I've been on all the emails. And it's a resource limitation problem, like, they're trying for IPv4.
Yeah, I understand the problem and why it's a problem. And I have a solution, so I'm okay.
Yeah.
I just couldn't get it fully implemented today.
Okay.
That's why I can only do 35 versus the full 100. Oh, this is my total cost to date, $15. You know, for spinning up 40 clusters, that's pretty good.
I could have used my account with my $50 credit that expires at the end of the month,
Yeah,
and we could have doubled it,
yeah.
but.
Oh, wait, I'll take your credit.
I mean, I know you like.
These are all my requests. You can see I've been really fighting with them since the third. Some
Requested quota value, 300.
close, some, I've been,
Request date, 9/7/7.
yeah, it's been a battle.
Okay.
This is where a good architect to work around the limitations is
Yeah.
important.
There you go. And probably, the time. Like,
Yeah,
there's never enough time.
wow. You're very gracious. Are you kidding? We're nerds. We're StarCraft junkies.
Yeah.
oh, yeah.
Oh, I should let you get my ass up there. That's why the computer didn't, they're not.
We play cooperatively on, we play against the zombies and
Yeah, there's one that has zombies and then there's one that has cannons. You can
super
upgrade them until they're
StarCraft
ready.
mod.
StarCraft.
yeah, it's a mod.
That's, the first time I played it was probably in New York City on Washington. My brother and his friend, like, we were in the same apartment building. We ended up with each of them in their own apartments playing, like, probably.
Right, yeah.
Done, you know, I sent this, I'm done.
Right, you actually had a disc, yeah.
And then the first time I actually got online myself, somebody told me like I was immediately.
Oh, yeah.
They sent the, like a minor into my account or something.
Yeah.
They made their little minor attacks. The thing I was using, not like this, what I was using to build. the
Right.
next thing, like, they know all these little tricks.
Yeah,
So,
Yeah, we don't play against 13-year-olds because they kill us.
yeah.
Right.
Is that right? Bill.
So this, just a little sneak peek. That's what our lab, that's what our lab looks like. See, you just type in the URL and it's an SSH terminal. Isn't that cool?
Uh-huh.
And it's all running. And it's all running in a pod. Yeah. So it's, goes out of this. Yeah, so if you look here, each one of these classes is a pod.
Okay.
So what's cool is, if a student is having trouble, I can literally shell into their pod and I can control stuff too. It's so cool.
Yeah.
So nerdy. Great for development though, because now you got a bunch of developers, each one, you can, as a teacher, you can be like, are you developing your code right? Or I can pull their code anytime and run it integrated.
I asked you like a month or two ago, if you have one developer.
Yes, I do.
Yeah, I'm trying to use that, just working.
Mhm.
And I'm not even like GitHub yet, which is like, you know, it's Azure.
Something.
And I'm like, and then she's part-time on this thing, and then she doesn't, and then I'm left with like, then I have to feel like I'm twisting her arm, just to give me what she did, and that's, oh, it's not ready yet, it's like, I don't care. I might have to finish it.
I forgot I still.
I'm trying to figure out how to get her into the habit.
Right.
Or to break down whatever the existence is.
You know what? It's fear. People think you're going to see their work and it's not complete and you're going to think negatively of them. That's usually the biggest fear.
And so, you know, I might have.
You'll have to
caused them a
introduce
little- But yeah, it's getting over that.
The water's right there. You got nice in the sunset. They have like.
Just got to keep pushing them.
Working on it, yeah.
I think they have a little. Sometimes it's, yeah, we got a question. It's very. Where do you go? About that part.
See the other ring. Yeah.
Oh, yeah.
So when the pizza arrives, we'll know.
Oh, is that what-
Yeah. See, I put look, we got to work as a team here. See, notice the Tampa Dev leadership, they know where the pizza's coming.
I was thinking, how many people can squeeze through that door? Like trying to evacuate 200 people from there, place like.
Oh, they see themselves now.
He's looking at the camera.
It's because he can see my screen.
Oh, you- they
Yeah,
can see?
yeah, they're like,
Can we
oh,
wave at them? Can they see us?
they can't, they can see me. Are they waving?
No, yeah. They're all looking. They don't see that.
Yeah.
That's Charlton? What now?
Yeah, I have them on me. Let me,
There it is.
pizza. Everybody's like, I don't want to lose my seat. Okay, everybody, pizza's here. Yeah.
It's a pretty wide. I got the front. Right? I can ship that work. We all like to. I know. That's all right. That's like what? Well, I'm gonna have to. Pretty cool. I like being outside.
Suggest the switch.
Huh?
Suggest the switch.
So that's what supplies all those.
Oh,
So
I was thinking.
that way you can plug it in, so you plug it into your network.
Yeah.
Plus.
I was thinking. We were wondering. Probably gets out of 6 4 anyway. Just got some cabinet out stock, so you're still going like 7.
Just whatever.
Yeah.
And if it's shorter, it's.
Is there?
I get credit for less work.
It's true, it's true. Same credit, less credit. Gets you some credit, but we got that, a lot of hungry people. Yeah, there's much water bottles there, soda as well.
This is.
Sitting down over here, there's stage 11 pizza. So I'm gonna say. Now, we have to have a, well, really nice talking. And, don't like say like, you know, try to bring up in conversation, so maybe this, keep it in your pocket and wait for that opportunity. I think really wants to do part of it. Well, so she was telling me she was gonna like art, but I'm not like. She says that whatever she does, she can't be satisfied with. You know, like with piano or music, you know, there is. Like, she can, okay, so she pushes this, she pushes that, she does that, she gets to this. But artists.
Yeah, it's also just the next one.
You know, I like it, but actually I really page control side.
What are those? Guys.
Yeah.
Sorry. Oh,
Awesome.
She just. Or whatever, so. There you go, yeah. Or you-
Okay, so actually we have a 40
It's good, just kind of.
guys.
And I go, well, let me tell you this. If you
So now you're trying to get a footboard.
Yeah.
Yeah.
going and trying to agree that you're not ready to use, or that you don't enjoy, or that you don't think it's gonna benefit your life, you know, why would you, you know, why would you go and feel some first like 3, 4 years? Working with it,
Listen.
enjoy it. You know, you can have 2 assistants, you know, and so, I don't know. I know, she's like, I don't know what I want to do. You don't have to know what you want. You know, you have time, you bring the social, you know, you're so feeling this. I was like, well, you have to be about it, but. You know, and I told you, you know, I go, think about this, go, what if, you know, you continue piano throughout high school, you know, you get your senior year. It's just like when it comes to you and says, I wish you would work at school. And her eyes kind of lit up. Well, she was like, I think that would be awesome. Conversation, you could take it for. So you could get something that way. Well, what am I going to do? Music. Well, sure. It's such words, you know, we have to tell them. So they have a great music program, and 2 classes for careers, and she don't know about your own. They just could use your musical background. It's just keep covering that you go about learning, you know, because it's a passion versus a big part of your life. She's saying so said you could be a music producer that you want to, you know.
So yeah, very. Yeah, now she's. That's the.
The line's gone very early and.
You don't think. Yeah, thanks. So before.
Eat and then we'll move you.
Two.
Sounds perfect. One thing at a time. Some Parmesan.
Oh.
Yeah.
Hey,
Don't know how messy you are.
Yeah.
You know the answer to that.
Yeah.
Pretty messy.
These two different.
Yeah, I feel like things are moving along. All right.
You're just having a conversation.
Sometimes I look. Yes, so. Unless you're out of these times. It's like. Exactly. Won't be there. No. Exactly. It's like. 6.
Without that, there's no more.
Yeah. That's.
Actually, what I can do, turn it this way and just sit right here.
What I was talking about.
That would be the smart way. I'm like, oh, I'll be all the way over there. Oh,
Yeah, cases are- yeah, cool. Thank you, everyone.
we just came off mute. Oh, yeah. Yeah.
All right.
So, hi, everybody. I am Cindy Singleton and Tony Singleton.
I'm Tony.
So, I guess let's go get ourselves started.
We had, maybe like,
Oh, yeah, weren't you supposed to talk first?
yes.
Please
yes.
talk.
So I'll be brief. Hopefully everybody's comfortable. Thank you for coming out and hanging out with us today. Thank you, Cindy, Tony, and the Temp Dev Group. My name is Staley Bryant. I am, the Senior Director here at Hayes. I've been here for almost 20 years. So I'm a dinosaur in this business. Don't look at me like that. You're so disappointed. Just joking, but, we love to be in the tech community, support the tech community. So we're super excited about having you here. We host a lot of groups, so please, we'll hopefully see you again. And Carolyn Estrella is on the other line. I think you can see at the top of the box, she's going to do a quick presentation and kind of just tell you about what we're seeing as a staffing firm in the market. Just kind of giving you some insight to that, and then we're going to let you guys talk technical. So thank you again for coming out and have a great evening. If you guys there's water, soda, ice over there, feel free, help yourself. And the restroom is right outside this door. All right, thank you.
Perfect. Well, thank you guys again all for coming tonight. I mean, it was a great turnout, so it's great to see reoccurring faces and some new faces, but welcome. And like Staley said, we won't take up too much of your time, but we are going to go ahead and do a quick QR code here. If everyone can scan this and sign in and take a little quiz. Won't take long, maybe a minute of your time. Should be about 6 questions. If you can go in and get that filled out, and then we'll share the results real time and talk business. You should be moving through the questions fairly quickly now. We're up to about 20 responses.
Can you go back to the big one? So people are trying to still scan.
There's a.
There you go.
There's raffle.
No, it's a question.
Well, I think the raffle is a question.
No.
Got it.
Not the raffle, I'm sorry. Just the questions. We'll get to the raffle in a little bit.
Raffle.
This QR should have brought you to fill in your name, who you work for, what your current work model is like, if you're open to new opportunities, things of that nature is what this QR code should have done. We're up to 38 responses. Give it a couple more seconds here. We're in the 40s now. There we go.
Amazon or Microsoft on Microsoft website.
Awesome. So as you guys continue through, you can see my screen here. It seems like predominantly majority of you guys are still 100% remote, which is, really exciting to see, but it's also very surprising, at least from a staffing perspective. What we've been noticing recently in the last, 3 to 4, maybe even 6 months, more and more companies, especially local to Tampa here, are going back into the office in some sort of capacity, whether it's twice a week, 4 times a week. There's a handful of companies that are even back full time at 5 days a week. So it's really surprising to see that about 60% of you are still fully remote. How do you guys feel about that?
Excellent.
Love it.
Perfect.
I like hybrid.
And I see a few others. I know this is anonymous. Does anyone want to pipe in and say what the other may be for you?
I will. I go into the office when I feel like it.
It's a nice schedule to have. I like
It's a
that.
great schedule.
That sounds perfect.
Awesome. This next one here, what is your biggest motivator when considering a new opportunity? And it seems technologies and projects takes the win here, which is really, exciting to see that that is surpassing remote work, because for the longest time, especially after COVID, it seemed like remote work was what was driving the industry. The projects kind of took a back seat, growth kind of took a back seat. Money has always been up there, but it's cool to see technologies and projects, especially with, you know, machine learning and AI and all the new things coming about in recent years. It's really exciting to see this. And then last or not least, new year, new me. Seems like 55% of you are open to a new job currently. And, I will say maybe it's because you're open to new projects. Maybe you want the growth. Maybe you just want to grow within, more money or stability, whatever it may seem. But more than half of you are open to a new job, and then 34% of you aren't open, but are always listening to what's out there. So you've come to the right spot. We definitely want to walk you guys through a few things that we're seeing here in the market. And currently, these are hot jobs that we have open that are actively interviewing candidates. These are all, we obviously have many, many, many more than these, but these are the ones that are hot moving right now. They needed someone hired yesterday. You can kind of take a look at what the skill sets are, whether they're contract, whether they're perm. I divided it out by remote and hybrid and on-site. There's a lot more hot jobs that need people in person and in the office than there are remote, as you guys can see from here. And, it varies from 3 days a week to 4 days a week, 2 days a week. But as far as fully remote roles, there are still quite a bit of them out in the market. What questions do you guys have for me?
How to find this position? At your LinkedIn page, you have 7,000 of open positions.
Yeah, no, absolutely. And these were just the hot ones that we pulled as of, a couple hours ago. We saw which ones are moving and want to make an offer ASAP. If you go on our website, there are thousands and thousands of open roles. And certainly we can get you connected with a recruiter based on what your skill set is. And you guys can go through those and see really what matches your skill sets and where we can get you plugged in. Perfect. And one last screen here. So currently, we are running our biggest campaign of the year, and we actually need your help on this. So every year, Hayes pushes out globally, we push out a salary guide that gives insights as to what people are making in the market across all specialisms, across all skill sets. And, to push out these salary guides, we need real life input on what you guys are making, what you guys want to make, what you could change within your role, within the business, things of that nature.
Yeah.
we are going to run a raffle at the end of this. And if you guys scan this QR code, it will take you to a survey. It will take 8 minutes to complete, so do it at your own time. But around each of the rooms, you will see another QR code to scan. After you have completed the survey, there will be another QR code to scan, and that will just ask for your name, and that is putting your entry into the raffle saying you have completed this survey. We will do the raffle right at the end, right after Cindy has wrapped up. It looks like I just took a peek, and it looks like about 12 of you have already entered your names, so definitely get your name in there, complete the survey, and we'll be sure to we'll pull a name at the end, and that person will win some goodies, some Haze swag. Thank you, guys.
Yay.
Thank you.
Thank you. All right. Slideshow. Play. Ah. Okay. Hi, everybody. I'm Cindy Singleton and Tony Singleton. We do a lot of work with Wicked Solutions, so you're going to see the URL Wicked Solution in your labs today. We also do a lot with Raspberry Pi clusters. So if y'all are interested in Kubernetes and Raspberry Pis and want to experiment, we can help you with that. But today, our presentation is going to be on AWS and deploying Kubernetes via Terraform. No, I am not. I don't care.
She's like that, you know.
Yeah, sharing is caring. All right, sorry. Okay, sorry about that.
Are you guys going to screen share?
Yeah. Just I have to allow. I might have to drop and re-come back because I had to give permissions to share my screen.
All right, cool. Thank you.
Okay. All right. So, can everybody see my screen okay now?
Yes, we see it in the conference room.
Okay, perfect. All right, so let me go ahead and start. Okay, so basically the goal is we are going to use Terraform to deploy something called EKS. This is known as, it's basically Kubernetes for AWS. So that is the goal. We have an agenda for today. The first thing we're probably going to do is, because it does take a while for these deployments to run, we only have 35 labs that are available. So what we may do is, to run the lab, you just need to have a web browser that you want to, if you want to type in the command. And right now in this class, it's going to be deploy. If you want access to a URL to run a lab, we can hand you a little strip. It'll give you one of the 35 labs, and then you can type in the URL. Or if you want, we'll be sharing it also on the screen as well. So I'll first start off, because this is a workshop. Does anybody want to access their own little lab environment? Perfect. Yeah. So I'm going to go ahead and stand, because sitting is hard. I can't see everybody. So while he's handing them out, the rest of the class is going to be what is Kubernetes. So, you know, a lot of people have heard the words, they hear Docker, they hear containers, but they don't quite know what it means. So we'll be explaining that. Also, what's Terraform? You're hearing all these buzzwords: Kubernetes, Terraform, AWS, EKS. So we're going to try and give you a couple simple definitions as to what they are, and explain it in an easy, digestible capsule. What are we deploying? Elastic Kubernetes services. This is, you'll hear AKS, that's Azure Kubernetes Services. All the cloud providers have their own 3-letter acronym for Kubernetes that they can trademark. And so you'll hear different words, but it's Kubernetes. The difference is who's managing it. In this case, we're going to have Amazon managing what we call our control plane. I'm going to do a high-level overview of Terraform code. It's kind of like a hello world. Explain to you, there's typically 5 components of Terraform. We're going to talk about 3 of them, which is basically a variable, a resource, which is what you deploy, and what's called an output variable. Output variables are useful because when Terraform is done running, you want to get a listing of, like, what's the URL I'm supposed to connect to for my website? Hint, hint, it's going to be the last thing that pops out of our deploy script. Going to also verify the deployment that EKS cluster deployed okay. This Terraform script that we're writing is going to deploy a Kubernetes cluster, and then is going to install an Nginx web server with high availability, with redundancy, going through a load balancer. And in the end, it'll spit out a URL that you can then click on, and it just gives you an Nginx hello world type of website. And that just verifies that your Kubernetes cluster is up and it's running okay. But at the end, we like to leave no trace behind, because these deployments are coming out of my bucket. I want them destroyed. If you don't destroy it, don't worry. I'll just still destroy them at the end. But the more of you that clean up, the less work for me. And then, of course, we'll do some questions and answers. I know we have, I think, until about 8:30, but obviously I think Hayes, they want to do the raffle. So maybe we'll try and shoot for 8:15 so they can do the raffle and you all can get your goodies. So with that,
We do still have some spots left for anyone that wants to do it themselves. So if you'd like, just raise your hand and we'll go ahead and get you one of those spots.
so the URL you're going to try and go to will basically be that student number that you have, .wickedsolutions.com. And you should see, is there a question?
Do we need to log into our AWS accounts for this?
Oh, absolutely not. No, I'm too lazy for that. I am the most laziest teacher you're going to meet.
Lazy, hell, you spent all day.
Don't give away the magic. Don't give away the magic. And besides, who knows? We'll see. This is our first live scale of this solution, so it'll be interesting to see if it goes smoothly. Demo gods don't always work, so if not, we can talk about why it didn't. So once you go to it, you'll basically do a /deploy.sh. This is running a shell script that will execute 3 different components that we're going to talk about. One is the hello world component. One is the EKS component, which is deploying the cluster. And then another one is deploying the, I said a K8S, which stands for Kubernetes. Just if you ever wanted to hear Kubernetes and K8S, again, tech people are lazy. We don't like big words. So we say Kubernetes is 8 letters. So it begins with a K, ends with an S, and 8. So that's where you get K8S. So, okay, so I'm going to leave this up for a second. Go ahead and hit your deploys. If you hit a deploy, you should start seeing stuff going, and then open another tab and type in your student code again, because it's going to take about 15 to 20 minutes for this script to run. And the reason it takes so long, okay.
Open another tab.
You're going to open another tab because this is the other tab is what you're going to be walking through the code with. We're starting the deployment first because it just takes so long to deploy. This is because when you're deploying in the cloud, it has to spin up what's called the control plane. As a matter of fact, I'm going to use this cluster here as an example.
So we should enter the second tab right away or wait for it?
No, enter the tab now.
Okay.
So basically all it's doing is it's creating a second SSH shell. It's no big deal.
Oh.
Not hurting anything. So I'm going to turn on my camera and see if it's on here. Hold on. So I can share a little bit. Okay, can you guys see, can we turn the light back on?
Yeah.
So just to let you know, I'm sharing this is the Raspberry Pi cluster, has 4 components. Basically, when you think of Kubernetes, you have the top one, which is called your control plane. This is the one that's basically used to tell what the other 3 nodes, which are running Docker, what to run. And so the reason it takes so long is it takes a while for AWS to create that control plane. So anyways, what is the difference? What is Kubernetes? What are containers and how do they relate? So we're going to go back in time. Years ago, y'all remember, those of you that are like old, basically we used to have a computer, a PC that runs on your desk. You got your hardware, you got your disk drive, you got your CPU. That's your traditional deployment. You load it and you start up your games, your Excel, traditional. What?
That's older than that.
Don't you be distracted. Don't distract. So,
Yes, sir. Yeah.
so now we have what we're called virtualized deployments. These are VMware. These are really popular. A lot of you have heard about it. Oracle VirtualBox, Hypervisor. And these became kind of really big because now you could run a Linux operating system on top of your OS. You could run a Windows operating system, but you had to have really big boxes. They needed to be like 32 gigs of memory, 8-core CPU. They're expensive because if you look at the way they're configured, I still have the traditional deployment, but then I got a hypervisor and I got another operating system, like a whole separate application. Well, Windows is about 4 to 8 gig in disk space. That's a big chunk of disk space for a VM. So VMs, while they're good, they're still very beefy and they still require a lot of resources. So then some wise little squirrel somewhere said, hey, rather than load the operating system like a VM, we can create what's called a container deployment. The container deployment, let's say your container is a Python application. I don't need a disk controller in my Python container. I don't need a Windows controller. I just need the Python code. So a container goes under the assumption that any code like disk drive, memory access, UI, all of that is still on the operating system in which it's running on. The only thing it contains is a little bit of code like Python that it needs. So what this means is your containers can be much smaller because a lot of the extra OS stuff is able to be accessed through the runtime engine. The disadvantage of this design is I can't run Windows on a Linux box. I can't run a Mac on a Windows. Like, containers have to match the OS they're running on. So that's the trade-off, right? Nothing's a free lunch, as it were. Any questions so far on how you can see what we're doing is we're reducing the size of the executable space that's required to run an application, such as traditional website. Traditional deployment, one website. Virtualized, I might be able to run 4 because I spin up 4 VMs, but those VM takes the 8 gigs of space. Container development, that website might be 10 meg in space. I can run 100 of them, 1,000 of them on the same hardware. And that's where you start seeing the advantage of containers.
To be sure, the ones on the right were Kubernetes.
Well, Kubernetes runs containers. I wanted to first explain what containers were. So, yeah, but that's a great question. So let's stay focused on the containers a little bit. If you look at this container deployment, this is a classic case years ago of something that was called Docker. Docker, we would run it. A lot of us run it on our PCs at home, and with it you can run something. But what happens if your PC crashes? The container that's running on it stops running as well. So Google had some engineers to come up with this idea of what they called Kubernetes. It's very similar to another thing that was done in parallel. It's called Docker Swarm. Very similar, where you have multiple Docker PCs that are communicating with each other. So if one goes down, the containers can fail over. And Kubernetes is exactly that. The reason we show the little 4-node clusters that we have there is we have one container per control node and 3 workers. We literally will unplug one and show that your website performance doesn't change at all, because we have things being load balanced, spread across, and when pods go down, the system automatically detects it and switches over. Why use Kubernetes? It's 100% container-based. That means developers and operations are happy. And the reason developers are happy is, who here is a developer? Raise your hand. Who here develops and compiles their code directly on their PC? Raise your hand. You guys, I'm a DevOps engineer. I don't like this. What happens is you install a version of a compiler. Let's say it was version 12. But the problem is, somebody in operations like me, we have our build server and we're running version 11. Now I ship your code over, I can't build it. If your stuff was built in a Docker container, the version of your compiler is stored in the Docker file. So that's why 100% container base is good. Fully support for our automation of high availability of containers. We can detect if the CPU utilization of a worker node is getting too high. We can spin up another worker node. It's called auto scaling. We can spin up another pod, another replica set. That's for the load balancing of multiple web services, APIs, whatever you choose. Databases, MongoDB, So you have the automated scaling. Also, we have support for diverse distributed systems. Really big word that means we support multiple operating systems. In Kubernetes, I can have a bunch of Docker containers that are installed on Linux. I can have a couple over here that are installed on Windows. Some might be Ubuntu. I might have some on Debian. Some even on ARM chipsets. I can control what container goes to which one because I can put labels on the worker nodes that says this one only runs Windows. This one only runs Linux. I might have another one that says this one has what's called a TPU, a transaction process unit, which is used in AI. Only run AI pods because that'll have the higher calculation rates. Support for canary deployments. This is a big deal too. So I have a web service like Netflix, and I got a patch, and y'all put out a patch where now we're going to change Netflix from red to blue. I don't want it to hit every person at once because there might be a bug. So instead, I might say a canary deployment where I'll say 10% of my pods all update and stop. With Kubernetes, you can do that. You can do what's called a controlled rollout. That's important because you might want to roll back if it didn't work. But so a lot of capabilities there with Kubernetes. What does it give us? Service discovery and load balancing. As soon as a worker node comes back online, it'll detect it, it'll come online, it'll start loading pods to it. Storage orchestration. If a worker node goes down and a container moves over, what about its disks? The disk drive might have used to be on the worker nodes. Well, now with Kubernetes, you have the ability too, where you can have NAS storage that'll move wherever your container is. Super useful if you're running a database. Automatic bin packing, kind of self-healing, secret and configuration management, and obviously I already talked about the multiple OS supports. So you can see a lot of flexibility. So I'd like the idea of Kubernetes as being able to run a data center and orchestrate what goes where through a single pane of glass. So this is the Kubernetes cluster. So now we're getting a little bit more in the nitty gritty. And I know you in the back are going to kill me because it's super hard to see. So I apologize. But basically, we're showing the three main components. On the left is what's called your controller node. It has your API server, scheduler, control manager, what's called an etcd database. It's basically a YAML database. It has a UI and a CLI that connects to it. If you hear Kubernetes, some of you that may have used it, you'll hear something called kubectl. kubectl just takes your command lines, wraps it into an API, HTTP type call, sends it up to here, and it executes basically YAML files. We can talk about that a little bit more. When you deploy a YAML file in Kubernetes, it's basically a blueprint. I want this web server pod. I want to have it create 2 replicas of itself, and I want to have a load balancer that spreads to it. It's like a YAML. It's a blueprint. It gets stored in the etcd database. So it goes to the API. API reads it, makes sure you have permission to write. You write to the etcd database. The scheduler then goes through about once a minute, and it says, does the etcd database, the YAML that I see, does it match what I expect to see based on what I know that's on my worker nodes? Oh, gee, this pod doesn't exist on my worker nodes. It tells the controller manager, go talk to the worker node and deploy the web service. So you can see how those first 4 components are controlling or orchestrating what container goes where. On the worker nodes, not quite as complicated. Worker node is basically running kubelet, which is basically what it uses to communicate with the control node, and it gives it status. I'm running these pods, these services, and this type of storage, and this is my OS. Kubeproxy is another Kubernetes process that runs on the worker nodes, And that way, sometimes you might have a service that says, hey, I want to talk from, I'm the web service, and I want to talk to my SQL server that's another pod somewhere else. Kubeproxy will help tell me where to direct my traffic to get to that other pod that's running somewhere else. And then you have what's called your container runtime. That's what runs your containers. This is normally you'd have been known as Docker, but Docker got bought out because they had a lot of people working on their board that worked for a company that said, hey, I'm going to buy you. So they got bought, started licensing. If you're like me, I'm cheap. I don't have a lot of money. So we started using Containerd. We branched off of Docker before the purchase, before the licensing, and now we start creating our own container called Containerd. And there's other types as well, Podman, CRI. You know, there are lots of other flavors, but they're all basically the same thing. Run a container, and if the container accesses anything from the OS, it handles the forwarding of the command to the operating system. And that is basically a Kubernetes cluster. It's just an orchestrated string of Docker servers. Any questions so far? Threw a lot out there, a little high level, but hopefully it made some sense. All right. No questions and glazed look means we're moving well. So what is Terraform? So Terraform basically is that you're going to write a piece of code, again, another blueprint, and then Terraform is going to take that blueprint, it's going to create a plan based on what it sees, and with it, it will then see, with what it sees, objects, do they exist in what's called a provider, which is, the provider is, what is Terraform trying to create an object to? In our case, we're creating what's called an EKS resource, so we're using the Amazon provider. You might have a Azure provider, you might have a DigitalOcean provider. We also have providers that are just straight up Kubernetes, where the Kubernetes provider, all it cares about is, does it have the config file, the security credentials to access that API from back here. And then with the Kubernetes resources you deploy in your plan, it'll read the credentials and execute it for you. So that's where you have the plan, Terraform looks at it, and then it compares with what it has to check the state, and then it gives you an apply. The apply is, this is what I'm going to build. I'm going to add these modules, I'm going to delete these modules, and you can choose yes or no. Or in the case of those of you that hit the deploy script, which we'll talk about later, I added to the Terraform apply command something called auto approve, because it doesn't be an automated script if you have to type in yes. So here's a higher level view of the three components. The writing, this is where your infrastructure as code is. This is that blueprint I was going to talk about that we're going to be going over later. And there's two parts to it, your blueprint and the state file. As you're running your command to deploy, later on, if you go looking into your directories, you'll start seeing a state file. When you first ran, there was no state file. State file is what Terraform thinks the state of the remote system is. So I'll give you a case in point. I have a Terraform script that says, build me the EKS cluster. First time I run it, if there's no state file, it will immediately try and build the EKS cluster. What happens next time I run that Terraform apply command? Terraform will say, I see you want to build the EKS cluster, but I see there's a state file. It'll look at the state file and say, I see an EKS cluster has already been deployed. So when you do the apply, it'll say, I have nothing to apply. So the state file is to stop you from redoing something over and over and over again. That's why that plan comes apart. So once it compares those two pieces of information, it gives you a plan. Plan is, this is what I'm going to do. Now you can also, plan and apply are kind of similar, because the difference between plan is this is what I'm going to do, it shows it to you, and then as soon as you type in yes, it applies it. The apply means make the change. So those are basically the Terraform, not a lot to it, pretty straightforward. Seems so simple, yet why don't we use more of it? What are we deploying? So now here I'm going to walk over to the screen and I'm going to show you, because it's kind of hard to see. But when you deploy a Kubernetes cluster, you're going to need a network for it to run on, right? You're going to have a switch to plug it into. In Amazon, you have what's called a VPC, a virtual private cloud. So we're going to, we were going to create one in your deploy, but somebody hit a quota limit. And so all of our containers are no longer deploying to their own VPC. You are all deploying to a shared VPC. And at the end of the class, I might talk about the whole, watch out for quotas. And basically, you have what are called public subnets and private subnets. In EKS, the private subnet is where your pods exist. And that's good because you don't want anybody from the outside world getting into them. But how do people from the outside world get into your cluster to access your website? That's where the public subnet comes in. What they do is they create an IP on the public subnet that gets forwarded through a NAT. And so what will happen is you'll end up, you'll see when you create, you'll get a URL that comes back. When you execute the URL, it's going through the NAT IP. That's where the quota is, because I'm only allowed so many IP addresses. You'll be using an IP that you go through, and then that gets forwarded to the pods. So it's important to be aware of how that's set up. Private is where you run most of your workload. Public is where you want to expose something to the outside world. And you want to be very careful. You don't want your database exposed to the public, because I guarantee you're going to get all sorts of things from all around the globe trying to hack you. Believe me, see it quite a bit. All right, so now we can review the code a little bit. I'm going to pull up a website. This is the, I have a GitHub account, Cindy Pi, because I like Raspberry Pi, or I'm fat, one of the two, and EKS class. That's our class that we have here. So what I'm going to do is I'm going to bring up that code right now. And almost there, sorry. So in the code, what we're looking at here, oh, whoops. So this is the code that we have. And here I try and document. I like to use the README, so you can kind of see this is kind of our definition of the class. So if you're a developer too, this is another important thing. Document, your code. Learn Markdown language. Strongly recommend it. Even the class presentation, I put a lot of that kind of in here, some of it with some of the code. And in here, let's take a look at this. We got a piece of code right here. Hello world. So when you first ran your deploy script, if you actually looked, if you did a cat on deploy.sh, so now you all have opened the other tab. You type in cat space deploy.sh. You will see something that says change directory 001, Terraform init, Terraform apply, 002, EKS, 7003. 001 is the most simple Terraform script. It's this basically hello world. You pass it a variable. You might want to change it. In the future, I might not want to say hello world. I might say, override variable hello world with hello Cindy, hello Frank, hello Tony. And then what it does is you have this variable, and then you can apply it to a resource. Now in our case, this case is we're applying it to what's called a null resource. I want this to run on the machine itself. And so what it's going to do, it's going to execute a shell command, because these are running on Ubuntu pods. It's going to do an echo of hello world. No big deal. It just kind of pops up there. But we're showing you how Terraform can grab a variable, you can pass it through, override these variables, showing how you can execute a shell script. I put a trigger on here, meaning every time you type in Terraform apply, remember that state file I was talking about where if the cluster already exists, don't run again? What if there's a case where I want it to run every time? I can put a timestamp that says always run when this is this timestamp. Since this is always showing the latest timestamp, it will never match in the state file. Because the state file will always have an older timestamp. So that's a good way to always run it. So that's why if you guys ran Terraform apply and I didn't have this, you might not see this echo command run but the first time. But for the class, I put a trigger. And then I have an output, hello world. So, and I'll go share a screen here in a second. So the output hello world is when Terraform is done running, show me the output. Every time a Terraform apply runs, it will always show you the output. So that's important if you always want to make sure, like, is this the link I want? Or maybe I need this information because I'm going to use it in some other script or whatever you choose. So let's go take a look at There's also a teacher pod. So in the hello world, let's look at the state file first, since this is already run. You can tell the state file doesn't really have a lot in it. And it's pretty readable. So also, do a lot of work with software security. State files, protect them, because guess what else they have? Exactly. They store them in the clear. Now, if you do a Terraform output, they'll like, oh, it's masked. You can't see it. But yeah, come on. If I can see a state file, I can see it. So basically what you're having here is it's kind of giving you information about what the Terraform is. There's my output. And then what are the resources? In this case, we only have one resource. It's going to be managed because that means Terraform is managing it. There might be a case where I have a resource that maybe I built manually. The Terraform detects it, but it can't change it because it wasn't the one that created it. In those cases, it's an unmanaged resource. We might use it, for example, where I might want to pull information about my VPC that wasn't created by this Terraform, but I might need it to fill parameters within Terraform, such as what VPC should I deploy my Terraform or my EKS to, something like that. And so here, this is the always run trigger. It'll never match because obviously I'm always putting in a new variable. So when this doesn't match during the plan phase, it says I need to run. That's the sensitive attributes that you can't see, but of course you can see it in the state file. And so you can see there's not a lot to a state file when you look at it this way, but they are kind of hard to read. You know, I wanted you to see it. So let's go ahead and run it and see what it does. So you can type in Terraform plan, and this is going to tell us what it's going to do. So it's not executing. The plan is kind of super useful if you want to see what something's going to be done before it changes. For example, I'm about to make a major change to a Terraform script that controls the entire company's network. Probably want to run a Terraform plan first, just to make sure, because it would stink if it dropped everything. By the way, hint, Terraform scripts have been known, having managed resources, if the state file's not done right, to wipe servers and bring them back up, and they're blank. So, good, but careful. So here, what this plan is basically telling us is it's telling us that we're going to be replacing this null resource. And basically, all it's doing is it's going to replace the always run, the date stamp. Known after apply is basically because it's going to be the timestamp of when I actually apply it. So this kind of gives us the information is I'm going to drop something, and I'm going to add. So it's like an update, replace. So this is one of those where if this was a SQL Server database, not sure I want this to be done. For null resource, okay. So always important to be aware of your situation. So we can then say, okay, Terraform apply. And it'll then say, again, shows you what you want. And we're going to say, yeah, sure. And there, it went ahead and it ran it, said hello world, did all that stuff. No big deal, very nice. So that's great for showing you the short thing, but we care about EKS. How do we deploy that? So now, let's look at that. Is the pace I'm going good enough? Too fast, too slow? Thumbs up. Okay, good. All right, so now we're going to go look at our code here. Now, in this case, if you look at this state file, it's crazy. Whoops. It just lots and lots and lots and lots and lots of stuff. So, okay. And I don't want to show too much of it because state file. Actually, who are we kidding? I'm deleting the credentials at the end of this meeting anyway, so that don't matter. Sorry. But let's look at what we're doing. So in this case, we're looking at what we're deploying. Let's see if I can. Yeah, that's good. That's good enough. All right. So here I'm going to walk over. This is what's called a module. So Terraform, you have your resources. And you also have something that are called modules. The modules are basically kind of like, you just saw that diagram of when I deployed it. You saw the VPC, you saw the network, you hear about the control planes, You got to worry about permissions. Sometimes I don't want to have to write every single one of those resources. I want somebody else to write them. That's what I use a module for. Module basically is somebody has gone through and they tested it and they know that there are 30 different resources that have to be done to deploy it. We'll handle it for you. You pass these parameters and we'll expand it out to all the resources you need to get a nice clean deployment. And that's what we're doing here. I'm telling you what's the source. So if you do a search on Google and you do Terraform modules, EKS deployment, you'll see something like this. This is a HashiCorp Terraform module. They're really popular in Terraform. I'm going to give my cluster name. My cluster name is a local variable that's derived off the host name. That's why when clusters, you all are doing your deployments, the name of your cluster is student whatever your number is. The reason is when I created that pod, I made the host name of that pod. Matter of fact, if you type in host name on your tab, you'll see the host name is your student number. That's kind of how I keep track. So anyways, you can then see that. Now in this case, if you look at your code, if you do a cat of this file on your computer, you're not going to see module VPC. You're actually going to see a hard-coded value. This was because of the bug I ran into. Again, couldn't get public IDs, so I wanted you to originally create your own VPC. You couldn't, so I changed your code for class. I hard-coded it so that you all go to the same VPC. So when you look at your code, that's what you'll see. And the cluster endpoint access is set to true because at the end of your deploy script, you're supposed to be able to connect to a URL that goes to your website. If I don't set this cluster endpoint to true, EKS, Kubernetes, will not use those public subnets, meaning nobody can get to your site unless they have access to your internal network. And we're not going to go over that, but that's a whole other ball of beans. And then with it, AMI type is like what kind of OS is it? As 8664 chipset. But what's really important here too is what kind of worker nodes. So in this case, we're only deploying one worker. We're deploying what's called the T3 small. Originally, I was going to do a micro, but there's a problem with the micro. Micro can only run support 4 IPs internally because of the size. You know, you're cheap, so they're going to restrict to your number of IPs. Problem is, we run 4 pods just for maintenance of the controller. You know, we have a pod so they're like, how do I handle this? We have a pod on how do I handle proxies, and a pod on a couple other things. So the micro was so small, I couldn't even spin up your website. So we had to go a little bit smaller. This had a pod limit of 4. This has a pod limit of 11. So it was big enough for me to put 2 pods to run your web service and your load balancer. So that's why you saw me move from small, micro to small. And of course, micro is the one that's free. Great. Clean up when it's done. So in this case, I'm saying min size of this node pool is 1, max is 3, desired size is 1. What this is basically saying is, I'm telling AWS, how many worker nodes do I want? And if it gets too crazy, if its CPU is 100%, I'm giving it permission to give me another worker, all the way up to 3. At that point, I'm like, that's it, it's done. Talk to the developers, they need to fix their code, I'm done. That's what's going on here. There is a bug. If you change this value in Terraform, it will not update it in AWS. This value is a one and done deal on Terraform. That just happens to be one of the bugs in the system. They haven't fixed it yet. So if you want to add more manually, you got to log on to the portal or run an AWS CLI command to raise your worker nodes up and down. Why would I want to add more worker nodes? For Netflix, I got Christmas coming, and I have maybe 1,000 servers that are running on my worker nodes, but suddenly I need another 10,000 more. That's where you're going to do it. What's nice is when it builds out all these worker nodes, they come up with 0 pods running. The control plane will see they have none. And anytime a new pod has to be deployed, it always goes to the one using the least pods. You can see it. It seems to be like you delete pods. The moment one gets below the lowest level, it'll always be the one picking up the extra work. And then the other one here is called an EKS add-on features. When these clusters are running in somebody else's cloud, they have their own rules. I can't just take a PC and turn it on in Amazon and say, hey, I should be able to see your network. I should be able to communicate. They have so many restrictions that they have Kubernetes can't run unless it has a translator to talk to their network. This is called a virtual private cloud container network interface. This allows this particular job, that plugin that I'm running, allows my pod to talk to other pods and other services like the load balancer, which we're trying to access. So that's why you'll see some of that. Without this, my pods can only communicate within the worker node. So we don't want that. So we're also adding a VPC. Sometimes when you're doing something, you got there's a lot of little black magic too. So anyways, any questions so far? That is deploying EKS. It's pretty straightforward in terms of once you start to understand it, use ChatGPT a lot, ask it to write you a sample plan, a sample TF file, sample hello world, sample EKS. It's amazing what you can do with AI. So yep, that's that. Let's see.
Sourcing like a Docker file when you start with Docker.
Yeah, it has a very JSON-y feel to
No,
it.
not the file, the source.
Yeah.
It's a lot like a Docker.
It has a feel, close, super close. So let's see how we had to. We're about 35 minutes in. So now what I'm going to do is I am going to come over to my web services over here. I want to see unauthorized. Give me a break. I'm here right now.
And at this point, you haven't said anything about operating systems, so that's assuming Linux.
I did mention that all these are running on Ubuntu. Yes. Yeah. Yes. Yeah. All right. Look at that. 15 bucks. I'm going broke, people. Help me out here. All right. Let's look at our EKS clusters. So what I'm looking at here now, just to give you a heads up, is I can see how many of our deployments have worked. So that's me. And looking at it here, about 18 of you have run. I don't know how many we hand out. I feel bad for
We handed out 19.
Let's say 19. Okay. Somebody. So anyways, maybe they hit above. So anyways, that's telling me that if you all go back to your previous tab. Yeah? I hear you. Oh, were you number 19?
Oh, no, I was asking, could it be possible to zoom in a little bit on your screen? It's really small.
Of course.
Thank you.
That a little better? There. How's that?
Yeah, that's perfect. Thank you.
So this is telling me that all your scripts should have completed. So if you click back on your previous tab, on the very bottom, you should see an output file that has a URL to it. Let me go see if I can, hold on. I'm gonna go pull a sample of one. I'm gonna even cheat. I'm gonna go into one of y'all's labs and pull it up. Also, no. At the end of the script, it says output.
Oh, sorry, yeah.
Yep, you can cut and paste that, and that is your web service. I'm going to show you what I mean here in a second, too. So just to let you know what I'm doing, I'm running a program called K9S. It also exists on your lab environment as well. It's super useful. What it allows me to do is I'm going to say, who's number 9? Number 9? So what we can do is we can shell into yours. I am now in your container, in your pod, and I can change directory over into your Nginx deployment, and I can say Terraform, because I only care about the output. No outputs. Hey, dun, 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 why did that not deploy? Resource template. Oh, a lock state. Okay, so something went wrong with your script. So interesting. So I'd have to look and see. So I should have been able to see your page. And see how it says temporary unavailable? That means your script is still trying to apply for whatever reason. If I had a guess, it would probably be related to the resource limit on the load balancers because we were running a lot of people. But let's go take a look at someone else real quick here. Well, I had a feeling we might hit a resource limit on something, so I apologize about that. So here is the output that if you were to cut and paste it, you should be able to then see your website. And this is what you're going to see. Oh, thank goodness, because I thought, man, that stunk. I would have another demo. So this is basically what you're going to see. For those of you where it worked okay, if you hit a resource limit, which we were kind of struggling with first thing in the morning, that's why we had to change the code. Yeah.
Is there more to do after this, or I can shut mine down and then just remember that?
You can shut it. It doesn't matter.
Like, is that, you know what I mean? Like, are we going on?
No, it's not stopping. We're not going to do it. I was just showing. I was just showing basically that you did the deployment. You can now say, if you're in an interview, have you ever deployed a Kubernetes cluster with a high availability web service?
Yes.
Yeah.
That's right.
You ran it with Terraform. You did it. You pressed the button. Does that count? Don't tell Hayes. So okay, so that's that there. Let me go now pull up to the next state. Okay, so basically that was where we just did it. We did the verify, we did the service host name, we made sure it worked. That's what you should see. And then all I ask is that you type in the /destroy, and that will clear it out for you. And we're going to play with a few more commands because we have more time. We have plenty of time. I was way too fast. Yes.
Compared to lambdas, what's the advantage and the disadvantage of
Sure. So the question is Lambda. Now, Lambda is basically AWS is running Kubernetes, and you are only running one container within that cluster. So you're running on a shared cluster, and they're running your stuff for you, and they're charging you a much smaller fee. Because like with this cluster, I got to pay for that worker node when it's up 24/7. Well, what if my website's only used 1 hour a day? A Kubernetes cluster might not be as cost effective as Lambda. Now, on the flip side, what if I have Lambda for, let's say, a Netflix website that I'm running a ton? Now that overhead for running 24/7 for a week might be more expensive than if I ran with dedicated servers. So everything, again, no free lunch. Everything comes with a trade-off. So Lambda is running on their hardware. So is the cloud, right? We just deployed EKS into the cloud, but I got to pay them for that space, and I got to pay a monthly fee on it. If I have hardware like the Raspberry Pi clusters in my house running my website, it's a one-shot cost. I only pay for the electricity it absorbs. So again, everything comes with trade, but I need to have more technical skill for this one. AWS has more technical skill. Lambda maybe more technical skill. So it's all about abstraction. So hopefully that answers your question. Okay, so any other kind of questions as we go along? Because this is the time for questions. Yeah. So I'm going to repeat the question so everybody else can hear. So basically what was asked was, the individual uses Azure a lot, and in Azure they have what are called ARM templates. And an ARM template is kind of like a blueprint, but instead of Terraform, it's designed specifically for Azure to deploy your network, your infrastructure, everything, same sort of thing, correct? It depends. So if it works and that's what you're using and you don't mind being tied to Azure and it's effective, stick to it. You probably have a lot more higher quality deployments with ARM than you do Terraform. Terraform's open source, it's written by community members, and it's supporting a large breadth of services. So they might get around to that new, Kubernetes, or that new, the new instance that comes up on Azure, but Terraform might not be there for a week or a month or a year, whereas ARM might be there right away. So Everything comes with a trade-off. Terraform sounds great, but it's not the answer for everything. Remember I told you, one of the Terraform's biggest problems, you don't handle your state files right, and this will happen. Some new architect or new engineer comes in and Terraform everything, and they put all their code, and they have one giant Terraform state file, and then they say, oh, I'm just going to change the network from 10.000 to a 10.100. And suddenly, all the managed dependencies under that network are dropped and rebuilt. That sucks. Good luck explaining that one to your boss after you've been working like 3 nights in a row to get it back. So state files are cautious. In this case, when we did the deployment, so I'll give you an example. When I do my Terraform state files, I have a state file for network that I hardly ever touch because I don't want it to be dependent on anything else. I have a state file for my Kubernetes clusters, which I hardly have to touch once they're deployed. And then I have my state files for my objects within Kubernetes. And those can be separated out where it's for this project, that project, and the other. So if one state file gets messed up, it doesn't hurt everything else. The only one that would hurt something is if I touched the Kubernetes cluster and it did a rebuild. So the only people that should be touching that are your SAs, not general people. So hopefully that answers it a little bit. Yeah, yeah.
So is it across all cloud providers if there's a problematic state file that will cause a life of the entire cluster, or?
It could. You could have one state file that touches multiple cloud providers, right? So the way it works is a state file is basically everything that's in all the TF files that are in the directory. So when we come back over here, let's go look at this again. Sorry. So in this directory, we have 2 files. There we go. So we have 2 files. In this case, it's just a main and Nginx. And the main basically is pulling the information to get the what they call the kubeconfig file. Remember I was telling you Kubernetes uses the API? You need a username and password to get into the API. That's what your kubeconfig file is. You talk to a White Tower architect, they'll be like, well, technically, it's a security certificate. I get it, but same concept. But if you have a lot of TF files, in your case, multiple cloud providers, Azure, and I decide I'm going to put everything in it, and you make a change, that state file ties to every blueprint that's in that directory. So generally, that's why you want to make things broken out a little bit more. And it's more of a cautionary tale. Almost everybody, when they first start Terraform, runs into the state file problem. Usually it's like, once they do a big oops, and then typically a few months later they do not so big oops, and then hopefully next year it's a much smaller oops. So yeah, back up. Let's see. That was a great question though. Any other questions?
I have a question in the conference room.
Yes.
Yeah. So my question is with regards to the state file. If you want to collaborate with other people, like, do you have any solutions for that? So like, yeah.
So I'm going to repeat for the class. This is a great question. So in our case, we stored the state file locally. Generally in a production, so when I handle any production or development at my company, we never store it locally. We store it on a storage account. You might have it in an S3 bucket. You might have it in an Azure storage account. You might have it on a NAS drive somewhere in your data center, and that can be shared by other people. What protects the state file is, which we just had when we were just going over the 7 deployment where you saw the lock. When a state file is in use, meaning a Terraform script is actively running, it locks the state file. So if we have one shared where everybody can see it, then you might do some development right to it, I might do some development right to it, and it shouldn't really be a problem. Obviously though, if I'm writing code on a resource and your code, let's say you wrote code and I wrote code, but we weren't the same, we could overwrite each other. Then you'd be like, okay, why did I just lose that pod? And then I'd look and I'd go, darn, my pod's gone. I'm going to rerun my Terraform. And then he'd be like, my pod's gone. Run it again. So you just got to be aware of it.
Okay.
Did that answer your question?
Yeah, thank you.
Yeah, no problem. And I had 2 questions here.
Young lady.
My phone is still destroyed. I don't know if that's meant to.
Yeah, I'll take care. Matter of fact, if you want to turn it off, you're fine. Don't worry about it. It takes 20 minutes to build. It takes 20 minutes to destroy. So yeah, don't worry about it. If it doesn't, don't worry about it. Actually, if you want, I created, and I think it's in here. I'm gonna a little cheat. I did create an auto destroy, which when this is run, you can close out of the window and it'll run in the background. Because I have access to all the pods, because you're all running on the teacher cluster, I can also SSH into every one of your shells and run it myself. Matter of fact, I have a shell script that I would run this auto destroy and it would just run in the background and I would then sit there and watch the clusters disappear. I'm lazy. I told you, I'm lazy. Don't worry. Oh, yeah. And then I'll come to you. Yes.
I have this GitHub site that we created
Yes.
to do all this,
Yes.
but it's on your AWS resources. Suppose I wanted to use my $50 credit.
Yes.
Go overnight and do all this.
Okay.
How would I do that?
Here's the secret sauce. Yes. I knew someone was going to ask. Okay. So never put your credentials on GitHub. Rule number 1. So how do I get my credentials in there without anybody seeing my credentials on all your stuff? I cheat. And I'll show you what I mean. Which is funny. Matter of fact, Tony and I were just laughing about it the other night because we ran Git Guardian on my repo and it said I was totally secure. And we know darn well that's not true. And I'm going to show you why.
I didn't think I was asking that question.
No, that's a good question. So in the bash RC script, I pull the codes from a website, dialog.com. The codes are there. These are 2 environment variables. If you do an env within your pod right now, and you do, you'll see some an environment variable that starts with AWS. AWS, I think, key, and the other one is AWS secret. Not username and password, certificate, but basically there. That's how I load them into your pod. I actually create this, and I have it runs as part of your
secret access key.
There you go.
Okay.
Now I'm going to deactivate that real quick.
Yeah, no, I know.
But that is how you get the codes. Now, if you actually were to look at this file.
So I could put mine somewhere.
Correct, and just change this URL.
Google Drive or something, or just.
Or you can use that if you want to start mining crypto or anything.
Yeah, absolutely. The good thing is,
the
good thing is it's going to take you 20 minutes to get it spun up.
Well, we started at 20 minutes ago.
So here you can just create this sort of file.
And then what do I do?
Well, no.
I'm actually like,
once that bash script is changed, when you first spin up you have deploy EKS lab, it will pull that and it will spin up your cluster.
Go back.
Sure.
Lower.
Yeah.
I clone your repo.
Huh?
I clone your repo.
You clone my repo.
Then,
you change the URL that points to a file like this that has your credentials.
Right.
And in the repo, we have.
Or what you can do when you log into AWS, you can set up your credentials.
Here it is. This is.
Realize how stupid I am.
No. I got it.
I mean, what command do I enter in the terminal?
Deploy EKS Cluster.
Okay.
This will spin up. You have to have Docker on your computer.
What is that?
What is Docker? You can't. Well,
yeah.
you don't have Kubernetes.
Yeah.
So what this?
Yeah.
To let you know, basically what we're doing here is you have Docker on your computer. This spins up a Docker image It also builds it, but it spins it up. And the Docker image it builds up is called a teacher container. The teacher container spins up and it has a little extra code in it that lets you build a Kubernetes cluster, because right now this is just a container. This then executes when you do the deploy. It builds a Kubernetes cluster, but it has an extra directory called O4 for teacher that lets you then build the labs that everybody uses. So if you were to look at my little teacher pod, which is right here, this looks just like your all's directory. 02, 01, 02, 03 runs the exact same, but 04, it runs a deploy student command. And what the student command basically does is it executes the student pod. Remember I told you how I use the host name to determine the name of your cluster when you run? I said it right here. This is a looping script, simple bash shell, goes from 1 to 35, creates 35 pods, each with unique host names. So when you log on to your class, you can, that's the URL, that's the host name, and that's how it all works. Also, you may have noticed in that code that I had on that website I shared, it had a domain name ID. The reason is Wicked Solution domain name. I needed that so that I can put the records for your class URL. Because when this spins up, it spins up a service with that long name that you just saw. But nobody wants to use that for production. You want something that's more readable. So I put a record called a CNAME record that said, take that long, weird, crazy name and put it in a student03.wickedsolutions.com. So, yes, question in the back.
Yeah, you brought up log files a second ago. Files are just inherently bad logs. So, do you have any experience with logs getting left? Things like that?
Yeah, so if you get a lock file, you can technically delete the lock file, and but you can sometimes run into corruption. So you can run a Terraform refresh where you can say, hey, look, I don't trust this state file. Try and do a refresh. But I will tell you, sometimes if you get a Terraform dies while running, it can take a little bit of manual effort of the state file itself to pick up a lost resource. For example, maybe it was writing an update on the state of a pod and it didn't finish updating all the fields. So now when Terraform tries to do a plan, it says, wait, these don't match, something's wrong. So sometimes you have problems with some of it. It's not the best answer. Terraform does have problems with failed locks. Sometimes you can get through with it okay, but sometimes there's been some late nights editing state files. Let's put that way.
Maybe it's not I don't know how I as developer get involved in all of this creation of Kubernetes script, because in my experience when I was developing self-contained services, we replicate the Docker file. Jenkins pipeline was the deployer.
Yep.
And you don't care about anything.
Right.
But, I see right now all the people is asking to the developers, do you know Kubernetes? And I don't know how much Kubernetes I must know to get a job. I don't know how I get involved in this. I don't know if this is.
Well, you got some code now. If you want to give it a shot. No, that's a great question. As a developer, how important is it as a developer to know Kubernetes? I'll be honest, a lot of management are like, yeah, they want you to know everything under the sun. But if you're a developer, the main thing you really need to know best is, how do I write my code to handle whatever socket, TCP, UDP connection to what port, to what database I need to connect to? That's really the main focus. It helps to understand Kubernetes in the sense of you understand VMs, right? Kubernetes is a little flashier VM. So if you understand VMs really well, then you're very close to knowing Kubernetes. But don't be surprised if you get some of these white tower people that bust your chops. They're like, well, do you know about namespaces? Do you know about secrets? Do you know about, what secret base 64 methodology do we use? It's like, come on, really? The main thing is do you know how your code is supposed to communicate with other code? It helps to be aware of Kubernetes and its existence. And if you want to play with it, great. For example, home labs, if anybody likes to do a home lab, Jeff Geerling does a lot with Kubernetes. It's a great YouTube channel. Recommend stuff like that. Play. The best way to learn is play. Hope that answers your question.
I would just say a lot of them want to have like a single horn growing out of the middle of your head. That helps with your complete rainbows.
Right. So, yes. And any other questions? This has been great, and hopefully I'm helping you a lot. Not something to be feared. It's just something takes a little bit of time to play with.
Out of curiosity, why don't have the Terraform state file like GitHub and PPRs? Is that because there's some
Secrets. Did we talk about secrets? Passwords, credentials? Did you not see my credentials up there? Huge no-no.
Did I not read them?
So now the only reason I'm okay doing it is one, I know security well enough, and I guarantee you that account's inactive and everything's been deleted, and I have quotas. Even if somebody were to take it, I like a credit card. I have a limit. You can't spin up an F16 server with 30,000 gig of memory. Ain't gonna work. So your Bitcoin mining with my account, good luck with it.
All right.
And plus, you'll get all your Bitcoins.
That is probably true too.
She knows more than you do.
I'll get that 10 cents. Great question though, but that's why we don't want to post on GitHub. True fact, GitHub is scanned by a lot of people, some good, some bad. Most cloud providers will scan these environments for their API keys and for the other credentials. And if they find them, they will give you a tongue lashing.
Just public or private too? I think it's bad practice no matter what.
Well, definitely not public. Private, no, private. You may need them, right? I mean, they're going to be on your server. You got to run them. You got to store them somewhere.
Well, Microsoft owns GitHub, so.
Well, true. I'm using Azure, and we're going to get a key vault, blah blah blah. But is that only a problem? Also, you think that's only an issue for public, or should you be nervous about having anything?
Even private, you should still be aware.
That's kind of
So,
yeah.
so general rule of thumb is, it's really not, if you can avoid hard coding, avoid it. But in this case for class, right, there's no way around it. You're running a lab. You need the credentials to create something. I can't hide that. So, public. So now I have to take the reverse stance. I'm accepting that everybody knows my code. I just need to change it. And as a matter of fact, it was activated this afternoon, and it's going to be deactivated tonight. As a matter of fact, I'll even show you. Now the class is over. Well, so what I can do now is I'll show you how I deactivate. It's super fast and easy.
So I haven't shut it down yet.
Doesn't matter. You're done. You're done.
No, that's what I'm saying. I'm not going to shut it down on purpose. Like, am I going to just evaporate?
Oh, so you just regular?
So basically, you come over to your credentials. I go to my user. And I go over to security credentials. And here's the access key. And if you now, I can delete it. I'm going to go ahead and deactivate for now. So deactivate means I can activate it later, but it will be deleted. So now if you're trying to run deploy, you'll get an error. It'll run, it'll read the state file, but you can't create anything. You can't delete anything. You'll still see stuff that's in your state file because that's not in AWS, that's on a file. Yeah.
So this, like, node, if you will, still running.
I can kill that. I can kill that when I want to.
I'm sure you can.
That's just coming over here.
It's just
what node? What? Tell me what node you're on. All right. So this is you have to set what's called a kube config file. Remember I was saying that file? Now, so here, Now this one I'm not going to share with you because I don't want you being able to mess up my Kubernetes cluster. What did I just do wrong? Did I not type something wrong? Wait. I did. That was a classic case. I locked myself out. I'll reactivate. That's right. Smart.
We had another question.
Go ahead.
So we're not running the code on Raspberry Pi somewhere?
Correct. So no, this is just these are just a demonstration of we talked about the costs of this would be a Kubernetes cluster that you might run at home, not nearly as powerful. Well, although actually these are about as powerful as AWS because the micros are, I think, 2-core, 4 gig of memory. These are 4-core, 8 gig of memory. So technically this is more powerful than the cluster you just built today. But this is useful for a home lab. You stick it in the back of your closet with some good ventilation, plug it in. You can run Pi-hole, you can run, Jellyfin, where you burn your DVDs legally and stream it like Netflix. So, which it's okay as long as as long as you have a license, but you own it. So yeah. But you can use it for home automation. One of the big things too, if you all are curious, Llama is a AI tool that you can now run at home, and it will run large language models for you, and you can actually ask it questions like ChatGPT, or you can load it a book and ask it to paraphrase it and do everything for you, and all that data never leaves your home. So it's pretty amazing. They were talking about with the large language models. I think it's what I tell you, 7 billion parameters per gig. So this is an 8 gig, and I've got 4 of them. So that's what's 7 times 32, and that's a pretty big language model. That's a lot of parameters that can be supported, and that's enough where I can probably load a model that gives me the history. Ask it any history question, it'll give the answer. Or they have language models that are related specifically to code. Ask it to write a Python script, it'll focus on that. ChatGPT is a general natural language model. It might be a little bit larger than you need. So if you ever want, you get some of these smaller ones and meet all your needs at home without everybody knowing. Trying to think anything else? Any other questions? Like I said, AI is a big thing. Kubernetes is good with AI. Kubernetes is good with databases, good with clusters, high availability. I think that kind of covers most of it at a high level. You all did the deployments. How did you feel about the class? Did you like being able to run stuff? Well, there you go. Great. Well, great. I think they're going to be doing the raffle here soon too. Oh, did you all want to see what the Docker file looks like?
Sure.
Because one of you was a developer, and that's what you are probably going to be more pressed on than anything else.
I have an highlight, I'm not sure.
Okay, so these files, super important. You were asking what OS we're running. Running Ubuntu. And then with it, when you did the class, I had to make sure you had all the tools you needed to run. So I have Vim, which is a VI editor, because if you're Linux, learn VI. wget, unzip, git, which I wrote twice. And then the other one is I download Terraform. You can see how Terraform, it's simply just, you're pulling the binary off of their website, Amazon CLI. That was what I was done to get a lot of some of the Kubernetes credentials. K9s. K9s was the tool that I was using. Super useful because it's a graphics tool without having to write all the kubectl shell into stuff. It's just a little faster. Still recommend, if you're doing Kubernetes, to know the kubectls or kubectl commands. But K9s is nice. And then I load, obviously, kubectl. With it, I also used a program called TTYD. This is a terminal emulator. This is what spun up the website that you all were able to go to, and it shelled you into it. Because I didn't want you to have to install anything on your computer. I wanted you to be able to go right in. If we had more time, maybe what we might do is next time is spin those up and have you all sit down with tables or something where you can actually type in a Terraform script. Type in, if you want to do a Python class, type in a Python code. Type in something and deploy it. Probably be a better way to go. And then here you'll see I copied that bash script file I was talking about because that is what I use for getting the credentials. So you all would be able to run it without having to deal with the icky part of typing in creds. And that's it. Now that's my script. And only, not much in between. The only difference between this one and the teacher one was one directory was added. I add that directory. Other than that, I'm running the exact same code you run. Eat your own dog food, they say.
Does everything in here run as admin, or do you create a user in here?
So every Docker container by default is your root,
Right.
within the container.
Right.
You can tell it don't be root. So if somebody SSHs in, you don't want to do stuff. But I'm root and all this.
Do you normally do that? Do you normally?
Most people do. You know, some of the more advanced, maybe they might put more security. Like if you download an MS SQL container, it'll bring you in as an MS SQL user.
Right.
So some of your more advanced ones, they don't want you being root because they don't want you changing what the container does.
Right.
Right? Because if I deploy this container and then somebody else was able to SSH into it, they can change code.
Right.
And now, you know, if it's a Python script, which is a compiler script, not so good. So if there's no more questions, I know we've got Hayes ready to kind of close it up. I want to thank you for your time again.
I'm gonna have Carolyn jump on and share. You got the raffle, so you can probably stop sharing.
Totally.
And then we'll be free. Everybody wants to get outside in the cold weather. Or is it hot? I don't know. I don't know what day it is. And we're raffling off. It's nothing crazy, but there's a Hayes lunchbox. It's got some good swag in it. It's got a T-shirt, a koozie, and then it's got my favorite Hayes socks. Yeah, I love these things. They're comfortable.
All right, you guys ready here? It looks like we received 16 people in the raffle. Are there any last minute stragglers that are just about done? I'll take that as a no. Here we go. You guys should see my screen here. Felipe, looks like you're the winner.
Oh, wait, no!
We didn't catch anything, girl.
You guys missed it?
Oh, no.
Oh, no.
Nope.
All right, we'll just spin it again, but we know Felipe won for Is that you? Felipe, no, you're not spinning again. Congratulations. Congratulations.
Congratulations.
Yeah, there you go. The socks are a hot commodity, I'm telling you. You put them on eBay, yeah, they'll sell quick. Well, guys, thank you so much. I don't know if the team wants to say anything, but definitely appreciate you coming out. We love hosting you guys. I would say to get some more pizza, but it's gone. But if you want a soda or water, there is some in there. The restroom's there if you want to, you know, before you leave, use the restroom. And thank you so much.
All right, thank you. Thank you.
Thanks.
Have a good night.
Awesome.
ask one question. My name is Alex, and I'm senior DevOps engineer. And if you are looking for speakers, I would really love to join as a speaker.
Yeah.
For example, I can tell about best practices of writing Docker files, or I can tell about Argo-CD, what's purpose of it.
Please send me, send me a message and I will forward you.
How can I find you?
Well, I'm on the meeting if you want, or I'll give you my number. Just make sure you text me your name.
Okay, I will find you.
I'm on Meetup. I'm on the Meetup. I put a comment. Just
Okay. Okay.
message me on Meetup.
I will send you.
Absolutely, yeah.
How often are you organized the same meetings?
Well, this is my first one, right? So we're doing another one in February.
Right, another one coming up in February.
We're doing the cluster deployment.
Excellent. Yeah. For the data center.
When I have opportunity to tell something.
I'm sorry, and did you have a question? Oh.
Yeah, I'm just using it. And, I'm just telling you that I'm ready.
Yeah, please. Yeah, reach out. This is great meeting. Looking forward to it.
Congratulations on a successful workshop.
Thank you.
I know they are not easy to pull off, and you guys, yeah. Whatever you made, even you made it over the speed bumps along the way. And
yeah.
Really
Well, now you know what I'm like.
Oh,
you
that
know
was awesome.
my presentations.
Yeah. Well, don't put ideas in my head.
You can pick it up.
We're gonna use that.
So yeah,
It's pretty sturdy.
Yeah. Let's.
But yeah, please reach out. That'd be great. I'm glad. Thanks for coming. Nice meeting you.
And yeah, we'll be doing a presentation in February where we're going to be talking about those and using those if you want to come to that.
Yes. Sign me up for that.
Yeah, that'll be good.
I probably have enough Raspberry Pis to make a cluster. They're all different states of disarray.
Yeah.
Creating an environment so I can do some development work in.
Yeah.
So one of the things that I ran into was if I start up the container and I do the mapping of the different ports, do I have to scratch the container in order to remap the ports? So
you might need to restart it.
Not rebuild it, but a run, and the run does the build of the container.
Did you have questions?
And then it has that full string of that port 8000 port.
You'd have to show me the example you're trying to refer to. I mean, you can change, like in a pod. In Kubernetes, we change ports all the time, and it doesn't hurt anything. It'll bounce the pod though. It'll shut down and restart. But you don't have to rebuild it. You may have to rebuild
boards that are actually
Yes, you have to rebuild the container if you're changing the exposure port
and the board itself.
inside the container. You know where you say Docker exposed port?
Yeah.
If you change that, it is a rebuild. That's the image.
So then you have to rebuild the image.
Correct.
Yeah, I get
Sorry.
that. But what are the hats? I can
So this is the hat right up here. That's your PoE hat. That's what gets
Okay,
it.
I guess I wondered, because I didn't remember my Raspberry Pi having power over Ethernet.
Yeah, are you using
3s, 4s? I think I've got a 3 somewhere and a 4 somewhere. I don't have any 5s. Ever since COVID, hard to get.
Well, if you run it, you know it's really common.
We can have it, but they're still very
What's real common, you'll see they'll do a Docker run command, and they'll say so let's say for example, I expose port 80 for a web service. I'll say Docker run -p 8000 : 80, and now I've remapped my local port 8000 to go to 80 on the container.
Right, but then every time I start a container after that, what's the little thing there with the yellow tape?
Yeah, that's, and you can see, those are the older version of the hat.
Reach out to me later. I'll have to look at your
You
code.
can see that.
It shouldn't be as hard. You're
It's
making
got
it
this
sound hard.
high-tech version.
So I'm thinking we'll have to.
But yeah, that's basically it.
Because ports aren't too bad.
But in the image itself,
That has to be.
metal fans, heat sinks on all of them. Slide over on the right. And we were talking about the layer which is just the load.
Does
I'm sorry, what's your name? Billy, I'm sorry.
Some sort of OS.
Yeah, you almost have to run them with the heatsink.
Yeah.
That
Yes. Yeah.
even if it's super
So you'll see, so for example, in my Docker file that I
This
showed,
version
first line says
is
from
like
Ubuntu.
$49 because
Those are what are called
has
fat
the,
containers. Sometimes you'll see
power
people
over
do
Ethernet.
from Alpine or from BusyBox. A lot more smaller. Yeah. Oh,
cool.
How's it connected?
Well, you have a power cord that plugs in back here, and then
Like
all of the
Promax
pies get their
and
power
stuff?
through the
Yes,
Ethernet.
no, I meant physically.
Proxmox, sorry, Proxmox.
What I do on these,
No, it's Proxmox. Promax
yeah,
is the
I
switch.
take the top off, drill the holes, mount them
Makes
a nice little
mess it up. So I was like, oh, I'll just replace the hard drive. Well, it's a Western Digital MyCloud. And apparently they firmware lock it, so you can't swap the hard drive. You have to buy a whole new thing.
Yeah, I don't know what use I would
I'm
have
not
for
a
a cluster.
home lab or anything. Like I'm a
Is
Java
it maybe
developer.
running
I started looking
home
at
automation, running home lab.
They
Literally with these, you can run everything in your house, you know, security cameras, television, everything that you can run through like an Amazon
But then
thing.
you
You can run it through these, and then you don't have anybody listening to you.
It doesn't show.
That would be nice.
Yes, you don't have everything you say getting reported back to Amazon.
I don't know. I haven't done that setup yet, so I'm not sure. We're looking to get that done. We're trying to set up a bunch of Ansible playbooks for the deploying of the Kubernetes pods to do jellyfin, NAS storage, gently or say, but we're not there yet. Yeah. Are you a home lab person too?
I have a little bit involved with
Digital assistants and stuff.
Yeah, and this is what you would run it on.
Yeah.
Yeah, so.
But yeah, wanted to
Would
say
you
thank
even
you.
need 5 of them?
Constructive.
Or can you just
Yeah, it's fun. I have to adapt to the
Depending on how
environment.
much you're running and how fast you want it to run,
Also, very cool.
you know, you might be able to run it on just one.
We're doing a class
Again,
in February on
you might
these,
want
and we're really going to
to,
go over.
Let's say you're doing.
We use what's called a control PI. Allows us to burn 4 SD cards at the same time. So we burn those in parallel, stick them in, and they already come pre-configured. And then I have it with the SSH keys that I then run Ansible, and that installs Kubernetes and all the pods that I run. So, and we want to put in with a website that you can click and say, I want jellyfin, I want NAS, I want AI. So we're trying to play with that. It's fun, it's about having fun. This is our weekends.
The different programs that you can run on the different things you can take with them.
Yeah, we're members.
And these are.
Yeah, he does a lot with laser cutting. All this was laser cut at the hackerspace.
Oh, okay, got it. Because I was going to comment. That's a cool case.
Yeah, thank you.
He does all of it. He makes
That's super cool.
I'm not that coordinated. I can't build this stuff.
So the February event, where is that? Is that a Tampa Dance?
That is data analytics event, and that's the one that Mike hosts. He's a gentleman over there with a beard. He'll be hosting it. So yeah. But I'm really glad you guys came. This was great.
Thank you guys.
Oh, yeah, pleasure. And did y'all say you were part of the hackerspace also?
No, I've been there a couple times.
Okay.
My wife and I were looking at joining.
Right.
But $75 a month is
It is a bit.
Yeah, you must have to have a project in mind.
Yeah, I talked to I forget the guy's name, the one in charge of the electronics department.
Paul.
Paul. And I was asking him they're talking about what you could teach there, and then you split the cost with hackerspace, and you'll get some of your money back every month or whatever. And I was like, well, cool. What do you guys need me to teach? I know Java, JavaScript, all that stuff. He's like, you taught a Java class, you might get a lot of people to show up. You can do 1 day a week for 4 weeks in a row, whatever.
Right.
I was like, maybe.
Yeah.
Yeah, the more you teach, the more you learn.
Yeah.
Yeah, that's true.
I'm also learning a lot.
Yeah.
I just walked to a brand new team at work, and I'm doing another side project at work that they want me to do in a completely different stack that I don't know. So
Always something. Well, thanks so much, guys.
Thanks, guys.
Thanks for coming out.
Happy New Year and happy Wednesday.
Yeah, happy New Year. right, I'm gonna go ahead and start.
But yeah, we'd love to, see you and your partner at the February event. And you said that was the name of the group hosting that, data analytics?
Data analytics. Yeah.
Data analytics.
Also, like all the hubs in our Kubernetes, Terraform, all that stuff, they actually do care. So you think about cloud providers, and whenever I look at any of like solution shops, they're always.
So I'm just getting ready to run the auto close on everything.
Right.
Looks like it's 1 through 35. Okay.
And I've also found like a lot of, even in backend, a lot of the.
And then we can run because these will run.
Larger companies care a lot more about like service.
Do you have to reactivate your system?
Yeah.
I did. I just did.
Even James Bears, so like, Geico or any of those big firms are gonna care. But you're a small shop, they're probably not
Hey. Huh? Yes. Oh yeah, we heard you were going to be coming up.
Tyler. Hey, nice to meet you. I'm Tony.
Nice to meet you, Cindy. I'm so glad you came out. Now you can say you saw Cindy speak.
Yeah. You met her.
Say, well, she was pretty boring, but that happened. Good enough.
So how are you liking where you're working? Right. Right. Well, these events are a good way to do it. And, like she mentioned earlier, ChatGPT, huge resource for learning stuff. Because, you can ask it questions, you can ask it to, show you sample code, it'll write it all out for you, you can play with it, you can run it, you can work it.
Hi, my name is Erin.
I know shit about code, and I've been using ChatGPT just
Dipping my toes.
again, to learn, to play with it, run it, experiment with it.
Things you said, I'm like,
I've
no
learned
idea.
a ton of stuff, none of it that I'm ever going to use because that's her department. But it gives me a better idea and better understanding of, especially when we
Some
come,
of it is, yes.
because I do a lot of these.
So thank
Well,
you so
it gives
much.
me some better understanding of different stuff that I can do.
I'm doing another one in February
Oh,
on
there we go.
Raspberry Pi clusters.
Yeah, it's a great source
You'll
for
learn a
learning.
little bit more about OSs and ways you can learn without being an expert.
Yeah. Yeah, and again, that's another area where ChatGPT can help you out.
On Meetup?
It's on Meetup for the data analytics.
It's going to give you the information and kind of